All right, let's get started.
This period is so bad because none of us want to do anything.
Since yesterday, you didn't respect me.
Okay. Before I go through like example problems, let me ask, what are some issues you've been having? What are some problems you want to look at? What types of problems? There were a lot in the problem set. There's probably stuff that is more difficult than others. So we should really focus on those. Katarina.
Sorry, 6'5".
6'5". So solving radical equations. Okay. You want to all start with that?
It was terrible.
Is that cool?
What test numbers would never mind.
Okay, let's look at an example. Let's say, we'll do two examples. Okay, we'll do one where it's good to use U substitution, and then we'll do another one where we have a radical, and we're going to square it, and it will still have a radical, we have to square it again. Alright? These are going to be your 9-point problems at the end of the test. You know the 3 at the end? Okay, those are going to be what those are from. And remember what I told you the third one will be? Hypotenuse from Pythagorean theorem example? We'll do one of those too. No, sorry. Thank you, Alejandro. Thank you. Yeah, 6-1, I mean, you might as well consider it on there because you have to know it anyway. So, I think we learned 6-1 carried over to 6-2 and 6-3.
We did before the break too, right?
No, we didn't. Mike.
So what are the last 3 problems in it?
It's going to be, I'm going to do 3 examples right now. So one of them is going to be solving a radical equation where you might want to use U substitution. One will be solving a radical equation where you're going to have a radical, and when you square it, you still have another radical you have to get rid of. Not a radical under a radical, but the example where we had 2 different radicals. We have to move it over and square and FOIL. I'll go through an example. And then one with a triangle. Okay? So let's look at the first one. So we'll start with, out of those 3, we'll start with one with U substitution. Okay?
How do you know when it's good to use U?
That's what I'm going to go over right now. Let's say we have this.
Wait, what is U substitution, like the U?
Yeah, where you let U equal the radical expression and make it easier on us. So say we have 2 times the cube root of
2.
x plus 1. Let's say plus 3 times the cube root of x plus 1 minus 4 equals...
Why?
Is this going to come out as 3,240?
No, give me a minute.
Now come out as 2,246.
Okay. So we have the cube root, 2 times the cube root of x plus 1
Would this be
plus 3 times the cube root of x plus 1 minus 4 equals 6. Manny,
Would this be on the test?
this is a perfect example, sure. So this is an example of why you would use substitution. Can somebody explain why they might see this as one of those examples? Why it's worthwhile here?
Because the cube root of x plus 1 is like the same in both.
Yes, that's the key. If this was x plus 1 and this was x plus 2, you cannot use U substitution. If, say this was a cube root and this was a square root or a 4th root, again, you cannot use U substitution. U substitution is very useful when the same radical occurs in the problem in several different locations. So again, because of the fact that this is the same as this, it is very useful to use U substitution. Do you understand what I'm saying?
What's his face? We could just Mr. Bolton.
You tried.
I know, I'm so worried about Mr. Bolton.
So we start by writing let U equal the radical expression, which makes our equation look very simple now.
Does it equal the radical expression?
Okay? So, 2U plus 3U. Good. Combine like terms, right? 5U. Add the 4 over, so it equals 10. Okay? So combine like terms. So you use 2, but that's not the answer, right, Johnny? What are we trying to find? What's the original variable? What's the original variable?
X plus 1.
Just a variable. X, good. But this is... So, but we know U is set equal to this, right? So again, u is equal to this quantity, but u is also equal to 2.
So they're equal to each other.
Exactly. Remember that transitive property? The height thing. Very good memory.
They're as tall as
If
Manny,
you-
and
Go ahead.
Manny's as tall as
What?
uh, Jack Mullen.
I think I'm taller than. I'm taller than.
Yeah, then they're all the same. Again, if two things are equal, and then that second thing is equal to a third, then all of them are the same. So set them equal, please. Mahanor. No, so again, if u equals 2, you take the 2 here and you plug it in right up there for u. Okay? And now it's an easy equation to solve. Cube both sides, Alejandro. What'd you get?
Oh, 8 equals x plus 1 and then x equals 7.
Good. Okay? Again, so the goal here is to make it easier, but you break it into two parts. You solve for u, and since u came out to be 2, we go ahead and set that equal to 2 up top. And this is a 2 down here. Can't really see it too well.
What are you trying to get? X?
You're trying to get x,
You
yes.
don't have to do anything, just that. So like,
In the condition where these are the same radicals, it might be useful to call u and then go through the process to get x. But then at the end, Johnny, what do we have to do still?
Check.
Yeah.
you have to
Check. Absolutely. Absolutely 100% have to check all of these. There's a good chance that a lot of them are going to turn out to be non-solutions. Okay? Where do you check it though?
the original solution.
Yes, original. So go all the way up here and put 7s in.
So 85. Oh, wait.
Oh, it's moving too much. So 2 cube root of... Now, you have to show the direct substitution on the first step, but afterward you can do some mental math. So show the substitution first.
Mr. Howell,
Yeah?
are you have to like show or check on this test?
You have to show what I'm showing you here, okay? And I'll show you exactly what that means. So you need to show the first substitution line always to show that you're taking your answer of 7 and plugging it in here for x and here for x, okay? After that, you can start, Jules, doing some mental math, right? 7 plus 1, everybody?
8.
Cube root of 8. So this is 2 by 2. This is 3 by 2. Minus 4 equals 6. From this point, you could just say 6 equals 6 or show it. The 4's canceled. 6 equals 6. So this is your final answer right here. Okay, it's boxed in.
Brace. 7.
In the braces, yeah. So the word, Alejandro looked it up, it's brace. Remember we talked about what is this actually symbol called? We were saying squiggly bracket. Okay, brace. But again, the idea is this. 7 is your answer. Once you check it, now 7 is your solution. Okay? That's how I think about it. 7 is your answer temporarily until it's verified with a check. And then we can put it inside the solution set.
Is it just a coincidence that if you add 4 over to the 6 that 10 equals 10?
No, not at all. But remember, man, when you check, you can never move stuff over. You can never move stuff around when you check. Write that note to yourself, please. Because you're checking the validity of this equation. If you were to move this 4 over, you're assuming that this is valid because you're using the operation or the identity or the property of addition on both sides. By moving the 4 over, you're already admitting the fact that it's equal. But you don't know that. You need to check that. So remember, for a check, you have to do each side individually. You cannot move stuff back and forth in a check. Okay? If that wasn't like second nature to you, you should write that note down, please. It doesn't change the answer, no. But when you're checking something, you have to leave it alone. That's all I'm saying. Okay? Because if you move stuff around incorrectly in the problem, and then you move it around incorrectly again, your answer might check out even if it's not true. Okay? It could cause errors along the way. One where we have a radical that we get rid of, leaving us behind still with another radical though.
Is that just second time long answer?
Yep.
Second type of what?
Long answer.
Yesterday in office hours.
We've had office hours.
Yeah.
The equation was x squared joules.
I'm just supposed to wait for John.
Julianne.
All right, so for this one, this is 7, yeah. We have two options here. First, We could take this and move it over, or we could take this and move it over. Either way it works, okay? It works either way, and that's something that we need to really point out. It does not matter. But one way is definitely easier than the other, okay? The more complicated radical should stay by itself. So move this one over.
I hate
Good. Okay, so move the radical x over by subtraction. Johnny, how do I get rid of the square root on the left-hand side?
Square.
Good, square it. But if I square the left-hand side, what do I have to do?
The right hand side as well.
Yeah. And the right-hand side is much more difficult because the right-hand side, we have to remember what method must be used. What do we have to do to multiply the right-hand side? Yeah, FOIL or distribute, please, okay? The left-hand side is easy. But again, the right-hand side here, it's really this.
No, what? Really?
Really.
Why can't you just do
7 squared and root x squared?
Yeah.
Try it. Try mathematically other numbers. Plug in. It doesn't work. We proved that in class one day, actually. Okay? Remember, this is a quantity that you're squaring. When you square a quantity, it means it multiplies by itself. Okay? So it's going to get messy. First term, 49. Then outer is going to be 7 times negative root x. So negative 7 root x. Inner is negative root x times 7 again. So if you've picked up on it, you're welcome to just put negative 14 root x. That's fine. And the last part is going to be a negative negative, which is a positive. But what's root x times root x? Yeah, it's root x squared, which is just really x. Okay, so the middle terms, you can make 14 to make it easier. Okay? So you do not need to show this line. I'm going to cross it off real quick. Okay, I'm going to cross it off.
You add 7.
You can do the 7 in the 7 part to make that 14 at the bottom automatically. The question you said is, do you add 7? Well, John, the problem is this. We still have a radical, right? So to solve for radical, we have to isolate the radical. So we really need to move these guys over. Sure, but then we'd have to move the other one over. So let's leave this on the right-hand side by moving these two over. What does this become here? X minus x?
0.
Drops off. Negative 7 and negative 49 is negative 56. Equals negative 14 root x. Positive 4. Okay, divide by negative 14 on both sides. Negative 56 over negative 14 is positive 4. Square both sides. Okay. What is this happy face thing?
Plug it in.
Plug it in, yeah.
That's sad face.
John,
Are the juniors now doing this?
I have no idea.
Didn't you say our
trick.
Didn't you say our course is still harder?
Oh, because one of them was asking me for my textbook, and I was like, "What? How are you doing all work?"
Well, I mean,
This is not me.
oops.
This is what they all do though, Regis.
Yeah, that's gonna be something.
Regis is behind us in bio, and it's like, what?
Oh, snap.
Oops.
Sorry. They just got they got
Did I do something wrong here?
No, it's right, it's correct.
No, it's,
No, you didn't
3
say
plus
it.
6 squared is 16, by the way.
3 plus
Right,
16
so
is
it's
not even
3
7.
plus
Thank you,
4.
thank you.
It's a
Okay.
little late.
late in the
You don't get, never mind.
I get it. It's like midday.
Thank you. Now, what's the answer to this problem, everybody?
no, it's
No, 16.
16. Do you know how many people write 7 because they get 7 equals 7? Just be careful, okay? Keep seeing that. Be very careful.
I knew.
See, you did it. You did it. You heard it. I know, but you get what I'm saying, right? It's very tempting to write the answer as 7, but that's your check. That's not the answer. Okay?
Oh wait.
So our solution is just 16.
My mom said I didn't remember, so is that bad?
Neither did I.
It'll be alright.
Hannah totally is like really.
As long as, Mike, as long as you have the answer and you checked it, okay? If one of the answers didn't work, I hope you put reject, right? Yeah.
Ned was such a good grader.
Why didn't you grade it?
Enough, enough.
If you put 7, you would just, you wouldn't give us the grocery.
With what?
If I put 7, not the like for this problem, if I put 7. Remember how I said 7 first? Would you take off all of that?
Not all points, but you would lose like maybe a half a point at the end or something. Given a right triangle above, determine the length of the hypotenuse.
Oh, man. Does it matter which one you make A, B, or C?
Well, C does.
C, X.
C is always the hypotenuse, yes. Opposite the perpendicular angle, good. Right angle.
But you don't know if it's not from the school.
Yeah, but it's always.
Hey, John, tell me here, what type of method do you have to use to multiply in this problem?
Well,
Yeah. Okay, your favorite, obviously. Okay, be careful here, please. Don't just distribute that square to each term. You got to FOIL. So I'm going to write down the work at the bottom, actually, here.
this is gonna say like 15 minutes on the test.
It's not going to take 15 minutes.
Okay,
I'm trying to get rid of this line that I drew by accident.
It's not possible.
Doesn't work, the eraser sometimes.
Consider buying
Did you get a new sharpener?
I'm writing with white ink over it.
one. We have 3 erasers on the board.
Well, the white ink does not seem to
We
be
love
looking.
training erasers.
All right, I'm going to continue down here. So, a lot of work to do here.
Oh,
For. So,
4 minus 8
unless you
square
write
root
it out,
of
it
8
just gets like.
plus 8.
it's annoying.
Plus 4, minus 4.
All right, FOIL out the first part. FOIL out the first part. Mike, what do you got for the first part? Shh. Give me all the steps, Mike, even though I know you're probably doing them in your head.
Oh,
The 2 minus root 8, FOIL that out. Tell me what you get.
4 minus 4 would be, let's say,
Good. And the second part, Jules?
4 plus 4 root 8 plus 8.
Very good. And I like how you both are combining your middle terms in your head. That's very good. The negative 2 root 8 right here, showing up twice as negative 4 root 8, and that's what Mike said. And Jules mentioned this is just 4 root 8. What happens though to those? What do you notice? Yeah, they all cancel the middle terms. That's the key for this problem, if you notice this, guys. Okay? The middle terms, these cancel with these. Okay? Is that clear? Again, this becomes negative 4 root 8. That's positive 4 root 8. Drop them off. 4 plus 8 is 12. 4 plus 8 is 12. 12 and 12 is?
24.
Oh, I did 4 minus 8.
Okay. That's what I was going to say. Be careful of this negative here. Okay. Everybody sees 4 and they see this minus sign right here. And some people carry that minus sign over to the 8. But this negative 2 cancel with this positive 2 and this positive 2. So it might even be useful to literally just like do this in your mind. So you don't even see it anymore. Okay? And then you'll see all the positives. In your mind, not really. Not. Answer? John.
No, after this.
Okay. Answer? Root 24. Break it down.
Wait, why did you put x variable?
Oops. Thank you, Jules. Break it down. 4n. Not 3.
What about 8?
4 and 6, right?
Why can't you do
Oh,
8?
wait. What? Oh, I thought it was 12. Oh,
It's alright.
Oh, that's right, it's a cube.
Uh-huh.
Did you just say it's cute?
No, it's not.
Cube, I think you said.
I had a line.
You think
Again, 24 can be broken into 12 and 2, 8 and 3, 6 and 4, but the only one that's a perfect square is 6 and 4. And the 4 is the perfect square, reducing to 2. The root 6 carries down.
Do we need to
Okay.
break it down?
Say again?
Do we need to break it down?
If the question says find the value of x in simplest form, yeah. When in doubt, break it down. Okay? I'm not going to ask you to check this one. Okay? Did it work?
Overachieving.
Good.
How would you?
Sorry.
It should work.
You just plug
Okay.
it,
For the ones with equations, I'll ask you to check it. Now, here's the reason I'm not asking you to check it. No. You've come up with the equation yourself. A squared plus B squared equals C squared, right? So, you're not given an equation that you can check into. So, if you came up with the wrong equation and you got an answer, your wrong answer will work in your wrong equation. So, a check is no really validity here for you. You see what I'm saying? Let's say I wrote A squared plus B squared equals C instead of C squared. My answer would just be, instead of x squared, it would be x equals 24. And then if I check 24, in my incorrect equation, it will actually be true. Because the original equation was incorrect. So based on your original equation, your check might or might not work. So I don't want you guys to have this false notion that my answer is right because the check worked, when in reality, the original equation was actually wrong. Okay? So again, for this kind of a problem, you don't need to check. Alejandro.
Never.
Okay, wait.
Don't rush me.
We have
You
five
think
minutes.
I-
Should we do Jeopardy?
I'm something whistling in his ear? No. We haven't asked you. How did this 2 plus, they could switch? Like instead of 2 minus the square root of 8?
Where are you at? In the beginning?
Also in the beginning. Had they been switched the order?
What order?
What order?
Instead of having the minus 1 first, you have the plus 1 first.
Same answer.
You don't, the plus would not distribute, right?
It's additive.
Yeah.
It doesn't matter because it's this sign here, Alejandro, is never going to change. Okay, see right here? The plus sign will never change. You could have a minus here and a plus here, or a plus here and a minus here. Either way, they're just going to be reversed. They're still added together, though. Okay? It's a good question. All right. Other things you should know. You should know how to solve something like this. Oops. Hold on. Don't write that. Switch to x and the 4. Make it a 5, actually. Do that, please. Okay? So this was in your problem set. Who remembers how to do it?
Oh, no.
You shot your hand up and you had to look like I didn't know what to do.
I had no idea. I didn't even remember. Didn't you have a question?
No, I think.
Jules, go ahead.
He's divided by the root 5, and then you rationalize.
No, not yet. You're jumping the gun. There's x. X on the right side. You can't have x in the answer.
Divide by x.
No.
I got it.
Remember, you want to get x one time by itself.
Divide by root 5.
Can you square this?
Nope.
Can you square this?
Yeah, can you?
Nope.
Why not? Wait, but why can't you
Subtract
square
7.
with that?
Nope.
Why would
Subtract
divide by
2x.
You know what?
Subtract
Alejandro?
2x.
Mike?
Close?
Subtract 2x, Mike.
I said that was now.
You also said about 35 other things. So after like the first 3, I kind of think you're just guessing there.
But he never even figured it out. He just
Mike,
told me.
what do you do next?
My guess. Shh. Come on, man.
Why did you do that?
You'll see in a second if you can realize it. Or you try to figure it out, Johnny.
Did he do it?
Why can't you base it on
My answer, can you now? Can you?
Oh, I know.
There it is. You both did it at the same time. I saw that. Factor it out. You cannot. Here's the deal. Ready? Watch.
I heard it.
If you had started by dividing by root 5, you would have x equals 2x plus 7 over root 5. You can't have x equals x. That's not valid. It can never happen. X cannot be the answer for x. It'd be like saying, one thing is a function of itself. It's a cyclic loop that would never end. If you change x, then x changes. If you change x, then x changes. It doesn't make sense, logically. You have to factor out the x. So when you do that, take a look what happens. And now, x is alone. Do you see that? It only appears once. That's the goal, to get x by itself. So now what can you do?
Divide by x.
Not by x.
Root 5 minus 10.
Yes, root 5 minus 2. But what's the problem with this answer? It is not what? Yeah, the denominator is not rational. So we multiply by the binomial.
Conjugate.
That's the word, the binomial conjugates. Now, please make note of what I'm about to do now if you haven't picked up on this by now. Okay? The denominator. Those are binomial conjugates, correct? So the middle term is what happens to them? Cancel. So just do the F from FOIL and the L from FOIL. So first, root 5 times root 5. Negative 2 times pi. John, pay attention. Root 5 times root 5 is the 5 there. Okay? Don't worry about the middle terms because it's a binomial conjugate only because of that. 2 times 2 is 4, but you have a negative. That's what your denominator becomes. If you want to prove it, FOIL it out. You'll have negative 2 root 5 and a positive 2 root 5 in the middle, which will cancel. Numerator, what do I just do? Simply distribute. Okay, put your parentheses around there to remind yourself. So your answer, what does the new denominator become? Just 1, so you just leave it alone. Okay? I'm also not going to ask you to check this one on there. You'll see it on the directions. Okay? Alright, next example. Is this clear? Yeah. Sure, absolutely. There's no necessity, but you can. That works too. Okay? But no, that's a good point because multiple choice can be expressed either way, right? It can be expressed like this or like this. Either way. For the sake of time, I kind of want to do a few other new ones. But there, look in your textbook in section 6.5 in the middle, where it's like parts A and B were all those questions. That's where that is. All the part B's. Okay, if you want to practice more of them. All right. I want to take a look and see if I didn't cover anything specifically. You need to know your no solution terminology, right? So no solution can be written how? Like that? What else?
That's what I was gonna say.
Good. What else?
Or X equals, like, a little cross out.
Good. So just like that. Or an empty set. Okay, brace, nothing, brace. Say again?
That's just
No solution. Sure, you could say no real solution, but for these,
oh yeah.
it doesn't matter whether they're real or imaginary, there's no solution. Okay? But that's a good point to make when you're solving those other ones. No, I'm abbreviating. I'm just saying, like, for example, like if you have like a multiple choice and the answer is no solution in one part, right? You need to know what that looks like. Or if you have an answer at the end of your problem and there is no solution, you need to write one of those 3 things. So know which one to put. I know, it's loud, guys.
I think they're practicing for coffee house. It just might be.
Okay, next.
Let's practice for math.
Rules.
Coffee house would be better.
We need to be able to do stuff like this.
Oh, come on.
Okay? We need to be able to simplify these. We did these in like 6.2 and 6.3. Okay? So, first of all, you see a negative exponent, and right away move it where? The bottom.
Are you only move that one?
Correct. Only the thing with the negative. Nothing attached to it. Even if there was a number. If it was 2y to the negative 4, the 2 stays up top. Okay?
Why?
Because you would have to have parentheses around the 2y for the whole thing to move down. Just like here. If you had parentheses here, John, and here, then the whole thing will move down. Okay? Now, what kind of a root, Manny, turn around, are we taking here? What kind of a root?
Cube.
A cube root. So we have to look for perfect cubes. So break up x to the 7th into what? Higher than x to the 3rd. You can do better than that.
X to the 8. No. The 6.
6th.
Oh, then that becomes x squared.
Yes. Okay, so there's your numerator. Why am I doing this? Remember, you want your exponent to be a multiple of the index. The index is 3, therefore this exponent needs to be either 3, 6, 9, 12, 15, ... But in this case, since it's 7, the largest multiple of 3 below 7 is 6. The denominator, 54 is not a perfect cube, but something goes into 54 that is 27. How many times does it go into it? 27 times?
Oh, I thought, yeah, 2.
Yeah.
That's what
The result is 3. Yes, Mike. Now, what about the y to the 4th? How many should I bring over to the perfect cube spot? Katarina.
Y to the third,
And we're left with?
y.
Yeah. So what have I done here? Please identify in your notes if you don't notice it. This is all the stuff that's going to reduce. Remember how I told you guys? Put everything that can reduce in the front and everything left over on the right-hand side. The cube root of x to the 6th is x squared because we reduce it. Okay, we think about the fact that x squared times x squared times x squared gives you x to the 6th. Or just simply divide the 2. Okay? The cube root of 27. Mike, you already said it. Say it one more time for us. Is 3. Because 3 times 3 times 3 is 27. The cube root of a cube is itself. So the cube root of y cubed is just y. There's your coefficient. What's left over? All the rest of that stuff. You can put that in one cube root, by the way. Write it like this. Make it easier.
Does that have to be in braces?
No, because it's not a solution, Alejandra. It's a simplification. Okay, you're simplifying an expression as opposed to solving an equation. Let me see if there's anything else I want to really point out.
Point out the whole text.
Exactly. Can you just
Well, it's
show-
tough too. There's a lot.
Can you just show us the test? Like, give it.
Another example of this, and I'm starting to ignore that question if you've noticed. Okay, what about something like this? It looks very complicated, right? Because you have all these plus signs, and you know you can't take the square root when there's addends. But what can you do with the inside? What can you make it? Yeah, factor it. What are the factors of this?
2 and 4.
4 and 4, which is really just this. Which is really just this. Okay? We did that in class, but I want to refresh your memory. It'll obviously be different. You know, if you have something in front of the x here, you might want to take out a GCF. Okay? There's different methods along the way. Let's see what else.
Where can we find examples of that?
Examples of this one. I'm trying to think of what section it was in. I'd say either probably 6.2 or 6.3, maybe 6.4, but it's not 6.5, Alejandra. Just look for quadratics under the radical quickly, and you'll see that's where they are. Okay. What about this? Okay, and you have to figure out something like that. Okay? XY gives you 12. Z is negative 5. So it's negative 12 fifths.
That's your answer, 12 over 5.
So what's your 12 over 5? Why is it not 12 over negative 5 as your answer though?
Oh, because it's squared.
Yeah, a lot of people, here's the issue here. Remember? You think about the square root and the square canceling, leaving behind 12 over negative 5. But really you need to think about what's going on. You're squaring 12 over negative 5, which becomes positive, and then you take the square root. So your answer for this is going to be simply 12 over 5, not the negative 12 over 5. This is the absolute value thing you keep seeing in the book. If you look at the answers in the back, that's where you're seeing that absolute value come into play.
When there's a square under the radical, just drop that.
As long as you remember, if it's a negative, it becomes positive. Okay? Again, Alejandro, because of... That's really what the answer is. And we always say this, right? We always end up dropping like that. We have to remember that if the original x was negative, since you're squaring it, it's back to positive. So think of the absolute value. Okay? And if you want to check, in y1 on your calculator, graph this, and graph this in y2. and you'll see that they're the exact same graphs. Those are equivalent to one another.